A star collapses under its own immense gravity, and in the heart of this collapse a new form of matter takes shape, a neutron star. But in the rarest of cases, something far more powerful emerges. The magnetar is born. A neutron star becomes a magnetar when its magnetic field becomes staggeringly powerful, billions to trillions of times stronger than that of an ordinary star. This field is so intense that it distorts the very fabric of space-time itself, warping reality in a way that our minds can barely comprehend. A magnetar's magnetic field is strong enough to rearrange the atoms in any object that approaches too closely. If one were to travel toward it, the very structure of matter would be ripped apart as it entered this magnetic web. Yet despite the immense power of the magnetar, it is for most of us just a fleeting shadow, out of reach, hidden in the distant reaches of the cosmos. These stars are invisible to the naked eye and can only be observed by the faint signals they emit, quiet yet profound bursts of energy, like whispers in the dark. They are born from the ashes of collapsed stars, their magnetic fields a remnant of cosmic cataclysm, their energy immense. A magnetar's magnetic field is so powerful that it could in theory influence Earth from millions of light years away. The forces at play are so colossal that they alter the very environment in which the star exists, and yet we're able to measure their faintest signals stretching across the vast nothingness of space. Only in their aftermath, in the traces they leave behind, can we begin to understand the power these stars wield. A magnetar's energy is not confined to its immediate vicinity. The magnetic field ripples outward, stretching the fabric of space, distorting it as the star pulses. These waves, stretching and compressing space-time, move through the universe, bending light, shifting gravitational fields, and leaving a cosmic signature for those who know how to look. Yet the magnetar remains elusive, its true power hidden from our everyday perception. It is a silent force felt across the universe but never fully seen. The process by which these fields become so intense remains an ongoing mystery. What exactly causes the magnetic fields of some neutron stars to grow so strong that they form a magnet is not completely understood. Scientists have speculated that it might have something to do with the rapid rotation of the star or the nature of its collapse. Perhaps it's the way the star's inner core behaves, or the turbulent processes that occur when the star reaches the end of its life. The formation of a magnetar remains one of the most fascinating and puzzling questions in modern astrophysics. But one thing is clear: when a magnetar is born, the universe gains a force of unimaginable power, a force that will shape the surrounding space, bending light, warping time, and leaving behind subtle traces that reach us only after eons as faint whispers in the cosmic wind. Only took a few million years for such a violent event to occur in the distant reaches of the universe, and yet the power that these magnetars possess remains undiminished by time. In a sense, these stars are frozen in time, their magnetic fields carrying the memories of the cataclysm that birthed them. These cosmic giants, though unseen by the naked eye, exert a profound influence on the surrounding space-shaping galaxies, bending light and creating an energy that is unfathomable to us. Their existence is not a fleeting moment, but rather a constant force in the universe, present in the quiet, unbroken rhythm of cosmic evolution. The magnetar is both a product of death and a harbinger of creation. The violent collapse of a massive star gives birth to the neutron star, and in some cases this small and dense remnant of a once mighty star transforms into a magnetar. The energy that it radiates into the cosmos through bursts of high-energy X-rays and gamma rays seeds the surrounding universe with cosmic radiation. These bursts are brief, but they're powerful enough to be felt across the vast emptiness of space, carrying with them information about the star's nature and the forces at play within it. In the immense quiet of space, the magnetar pulses, releasing waves of energy that stretch across light years. Yet despite their power, these bursts of energy are often undetectable by human senses, and they remain largely hidden from the vast majority of the universe. In the same way, a magnetar's presence is subtle, yet its effects are far-reaching, expanding outward, in a ripple that gradually fades but never truly disappears. The magnetar's energy continues to affect the surrounding space long after its bursts have faded. When a magnetar is born, it sends a shockwave of energy through its immediate surroundings, distorting everything in its path. The surrounding stars, gas clouds, and debris become part of the magnetar's cosmic signature. Yet like an invisible hand, the magnetar reshapes the space around it with a quiet, unrelenting force. It is as though this star, born from the ashes of a supernova, is not simply a remnant of a dead star, but a force of nature that influences everything. It touches like ripples in a pond that slowly expand outward, reshaping the universe one pulse at a time, and the mystery deepens. How does the magnetar continue to pulse and radiate energy for millions of years, even though it no longer has the same raw fuel it did when it was born? How does it maintain its magnetic field, one of the strongest forces in the universe, without exhausting its resources? Theory abound, but there is still no definitive answer. It seems that magnetars are not static, but dynamic forces of nature that evolve and change over time. Some magnetars eventually lose their magnetic strength, fading into something more ordinary, while others continue to radiate energy long after the star has exhausted its fuel. The uncertainty of their long-term behavior only adds to their allure, and perhaps in this mystery lies their greatest beauty. They are not understood, not fully known, but they continue to exist, pulsing in the darkness, reshaping the universe with their unseen forces. Despite their fleeting moments of brilliance, magnetars live short lives in the grand scheme of the universe, lasting only a few million years, yet they continue to pulse and radiate energy long after their initial birth. These powerful bursts of radiation are a fleeting reminder of the violence that gave birth to the magnetar, and yet even in their brief flashes they leave a lasting imprint on the cosmos. In this sense, the magnetar serves as both a reminder of the cosmic violence that shapes the universe and a symbol of the quiet forces that continue to shape everything around us. The immense power that a magnetar wields is not contained within its own magnetic field. It extends outward, influencing everything around it. This magnetic field, a force so intense it could twist and tear apart the fabric of any material object that dares to approach, radiates outward with energy that shakes the very core of space itself. While a regular star's magnetic field is comparatively weak, a magnetar's magnetic field is capable of shifting the orientation of atoms within nearby objects. Imagine a simple compass needle held near a magnetar. The needle would be subject to the most extreme forces known to physics, its atoms tugged and twisted with a force that would cause it to break apart. Yet despite this immense magnetic strength, it remains undetectable to the human eye. The field is hidden, an invisible agent shaping the universe, with only its faint effects reaching the distant reaches of space, where we can measure them through specialized tools. In its wake, a magnetar leaves more than just cosmic radiation. It leaves a fundamental alteration of the space around it, a distortion that travels across the universe, ever expanding yet barely perceptible in its passing. The magnetic bursts from a magnetar are staggeringly powerful, often releasing more energy in a fraction of a second than the sun will release over its entire lifespan. These bursts come as high-energy gamma-ray and X-ray flares surging outward with the intensity of hundreds of thousands of supernovae, yet lasting for only brief moments, mere blinks in the eye of the universe. Despite their brevity, these bursts are strong enough to be felt across vast distances, their energy travelling through space, bending and twisting the very light that passes near them. These high-energy flares are a testament to the magnetar's immense power, its ability to pull in energy from its surroundings, compress it, and then release it in violent bursts that echo across light years. But here's the irony: even though the energy from these bursts could power entire civilizations for billions of years, by the time it reaches us, it is so faint that we can only measure it with the most sensitive instruments. It's like the faintest whisper from a star, a sound so quiet it can only be detected by those who know how to listen for it. The bursts, though incredibly intense, are not constant. Instead, they come in periodic intervals, a pulse that stretches across time like the ticking of a cosmic clock. These pulses are regular and predictable in some cases, yet their underlying cause remains a mystery. What drives these pulses? Why does a magnetar at its core continue to generate such intense bursts? And what causes these bursts to fluctuate in intensity over time? These questions remain unanswered. One theory suggests that the magnetar's internal magnetic field might slowly shift and realign, releasing energy as it does. Another theory proposes that these flares are the result of complex dynamic changes within the star's crust, as the powerful magnetic field twists and distorts the star's surface. But despite the many ideas proposed, no one theory fully explains the full complexity of magnetar activity. This uncertainty adds a layer of intrigue to the magnetar's enigmatic existence, making them one of the most mysterious and captivating objects in the universe. The magnetar's bursts are not just a byproduct of its magnetic activity. They are a signal that echoes across the cosmos, a faint yet unmistakable sign of the star's power. These signals, as they travel through the universe, give us insight into the star's internal workings. When a magnetar emits a burst, it's like a brief flash of a cosmic fingerprint imprinted on space-time, carrying with it the story of its birth, its evolution, and the forces that govern its existence. And yet, as we observe these faint signals, we're reminded of how much we still don't know about magnetars. Despite the advanced tools we have to study them, these stars remain largely beyond our reach. The light that we observe from them has travelled for millions, sometimes billions of years before reaching us, so that when we finally detect their pulses, we are observing a moment in time that has long since passed. Even though magnetars are often located millions of light years away, the energy they emit can still have profound effects. Magnetars have been known to generate gamma-ray bursts so powerful that if one were to occur close enough to Earth, it could disrupt the very atmosphere that sustains life. Fortunately, these events are extremely rare, and the closest magnetars are far enough away that their effects are not harmful to us. But this reality is sobering. The energy emitted by a magnetar is so great that it could alter the structure of a planet's atmosphere, stripping it of its protective layers and sending shockwaves of radiation across its surface. Yet here is the irony: this immense destructive power is locked away in the most remote reaches of the universe, so far removed from our lives that we can only observe its effects, and only in the faintest of traces. Despite the constant force at play, magnetars exist far beyond our immediate perception, hiding in the distant reaches of space, offering us only the smallest of glimpses into their vast unknowable power. As a magnetar ages, its magnetic field begins to decay, and its bursts become less frequent. The star loses its brilliance, its once powerful magnetic field gradually weakening over time. The irony here is that while the magnetar's energy is constantly being emitted in the form of radiation, this very emission leads to the star's eventual demise. The magnetar consumes its own magnetic field, gradually dissipating its immense energy. What's left is a remnant of the star. It once was an object that has run out of fuel, no longer capable of generating the energy it once could. This process unfolds over millions of years, a slow fading into quiet stillness, as the magnetar becomes just another forgotten neutron star. In this slow, inevitable decay lies one of the great ironies of these cosmic giants. That which makes them powerful also makes them transient. They are born from the violent collapse of a massive star, their magnetic fields a direct result of the chaotic forces at play during their creation. But eventually these same forces wear down, and the magnetar fades into silence, leaving behind only faint traces of the energy it once emitted. This cycle of creation and destruction is one of the fundamental patterns in the universe where every force is followed by an equal inevitable decline. Despite the brief nature of their existence, magnetars leave behind a lasting imprint on the universe. The energy they release, the magnetic fields they generate, and the radiation they emit all carry with them signatures that remain imprinted on space-time long after the magnetar fades away. These cosmic echoes stretch across the universe, a reminder of the immense power these stars once held. Their brief lives and powerful bursts leave a legacy that can be detected by future generations of observers long after the magnetar itself has disappeared. In this way, magnetars contribute to the ongoing evolution of the universe, their death a part of the larger silent dance of cosmic creation and destruction. The birth of a magnetar marks the conclusion of a stellar cycle, one that began with a star burning brightly for millions of years, its core slowly collapsing under the force of its own gravity. What remains after this collapse is a neutron star, its core packed so densely that it defies our understanding of matter. But for some stars, this is just the beginning of a second life. The magnetar in its infancy is a violent pulsating star, its magnetic field so intense it affects everything around it, pulling on space and time, bending both in ways we're only beginning to understand. As a magnetar's magnetic field grows in strength, it unleashes bursts of energy that ripple outward, sending waves of radiation far beyond the star itself. These bursts, like faint echoes of cosmic thunder, travel across the universe, their intensity fading as they reach the edges of space. Yet despite their distance, these energy bursts hold vital information about the magnetar's inner workings, providing scientists with glimpses into the nature of these invisible giants. The magnetic field that defines a magnetar does more than simply radiate energy. It warps the surrounding space-time, causing distortions that extend far beyond the star's immediate vicinity. The gravity of a magnetar is so powerful that it can affect the orbits of nearby stars, even bend light itself as it passes near the star. This phenomenon, known as gravitational lensing, allows us to see light that would otherwise be hidden behind the magnetar's intense magnetic field. Through this subtle distortion of space, the magnetar reveals itself in ways that are otherwise imperceptible. We may never see the magnetar directly, but the effects of its gravity and magnetic field leave an imprint on the universe around it, allowing us to track its movements and observe its influence on the surrounding stars and galaxies. Even though the magnetar's magnetic field is constantly shifting, its power remains remarkably stable over time. This magnetic stability is a key characteristic of these stars, allowing them to continue emitting energy over vast periods. Yet this stability hides a deeper mystery. What exactly keeps the magnetar's magnetic field so powerful, and how does it maintain this strength for millions of years? The answer lies in the complex interplay between the star's rotation, its internal magnetic dynamo, and the forces at work in its dense, compact core. Though the details of this process remain a subject of intense study, it is clear that magnetars are some of the most dynamic and mysterious objects in the universe, their magnetic fields both a product of their violent creation and the source of their ongoing energy. Ironically, this powerful continuous emission of energy, which sustains the magnetar's brilliance, is also the force that will eventually lead to its demise. As the magnetar releases energy, it slowly drains its magnetic field, eventually causing it to fade. While this may seem counterintuitive, how can something so powerful be extinguished by its own energy? It is simply a reflection of the delicate balance that governs all stars. As a magnetar ages, it begins to lose its magnetic field, and the frequency of its bursts becomes less regular. The energy it once emitted in violent outbursts begins to dissipate, and over the course of millions of years it fades into the background of space, no longer the active radiant force it once was. The same energy that made it a source of light and heat for distant galaxies now becomes a source of its slow decline. This slow burn toward obscurity is both the end of its life cycle and a reminder of the cyclical nature of the cosmos. Stars are born, they shine brightly, and then they fade their energy, contributing to the ongoing evolution of the universe. As the magnetar fades, it leaves behind traces of its existence in the form of the energy it has emitted. Gravitational waves continue to propagate outward, carrying the legacy of the magnetar's powerful magnetic field. These waves are invisible to the naked eye, but they are detectable by our most sensitive instruments, which can measure the subtle distortions they cause in space-time. Through these faint ripples, we can learn about the magnetar's past, how it was born, how it evolved, and how it influenced the surrounding space. The magnetar's death, like its birth, leaves behind a cosmic signature, a reminder of its existence long after it has passed into silence. And yet this silence is not the end, but rather the beginning of a new phase in the universe's grand cycle. The magnetar's energy, like the energy of every other star, contributes to the ongoing shaping of space and time. Its death leads to the formation of new stars, new galaxies, new forces that will eventually give rise to other magnetars in distant corners of the cosmos. The fading of a magnetar is a quiet process, its magnetic field weakening over millennia until it no longer emits the powerful burst that once defined it. Yet this quiet fade is not without significance. As the magnetar's energy dissipates, it leaves behind remnants of its existence, heavy elements formed during its violent bursts radiation that has shaped the surrounding space and the faint imprint of its magnetic field on the fabric of space-time. These remnants continue to influence the universe long after the magnetar itself has faded into obscurity, creating new conditions for the birth of other stars and galaxies. In this sense, even the death of a magnetar is not truly an end but a transition. It is a part of the ongoing cosmic dance where energy is never lost but transformed, where the forces that shape the universe continue to evolve, pushing the boundaries of what we know and challenging our understanding of the cosmos. Even as the magnetar fades into the quiet darkness, the legacy of its existence continues to echo across the universe. Its death marks the end of one star's life, but it also paves the way for the birth of new stars, new magnetars, and new cosmic forces. These new forces, born from the remnants of the old, continue the cycle of creation and destruction that shapes the universe. The magnetar's magnetic field may fade, but the energy it has released will live on, stretching across the vast reaches of space, influencing the formation of new matter and new stars. The magnetar is both a creator and a destroyer, a force that gives birth to energy and matter, only to eventually fade away, leaving behind the remnants of its power. This constant cycle of birth, life, and death is the heartbeat of the universe, a reminder that nothing in the cosmos is ever truly lost, only transformed. As magnetars reach the end of their life cycles, they fade from view, their once intense bursts of energy becoming quieter and less frequent. The extraordinary magnetic field that sustained them begins to dissipate, the star no longer emitting the same violent pulses that once shook the universe. Their magnetic field, though still vastly powerful by any other measure, becomes weaker over time. This gradual decay is a natural consequence of their age as the star exhausts the energy that once fueled its magnetic strength. But this process, though slow, carries with it profound consequences for the surrounding space. As the Magnetar's magnetic field weakens, its influence on nearby stars and galaxies begins to fade. The high-energy bursts that once travelled across vast distances and distorted light now become rarer, their intensity diminishing as the magnetar grows colder, quieter. Yet even as a magnetar wanes, its legacy lingers. The energy it has released over the course of its life remains imprinted on the surrounding space. The high-energy radiation it emitted continues to scatter throughout the cosmos, reaching distant regions and altering the conditions there. The magnetar, though it may no longer be the radiant force it once was, has nonetheless left behind a mark on the universe, shaping the surrounding space with its once imperceptible but now lasting presence. The heavy elements formed during its outbursts contribute to the creation of new stars and galaxies, seeding the universe with the building blocks for future celestial bodies. The magnetar's fading is not an absolute silence, but rather a quiet retreat into the background, as its once immense power dissipates into the ever-expanding universe. The remnants of a magnetar are a testament to the life cycle of stars. What began as an explosion of energy and magnetic power is now an object that fades into obscurity, its magnetic field weakening and its bursts of radiation becoming less frequent. But the magnetar is never truly gone. Even in its final quiet stages, it continues to influence the universe, albeit in ways that are harder to detect. The energy that the magnetar released during its most intense bursts will travel across the cosmos, lingering for billions of years, carrying the memory of its existence long after it has faded into silence. These echoes are a reminder that the magnetar, though it has lost its ability to radiate energy in such immense bursts, has forever altered the fabric of the universe. The quietest forces leave the longest-lasting impressions. As magnetars fade, they become a part of the larger cycle of cosmic evolution. The material from which they were made, the remnants of dead stars, is recycled, reformed, and used to create new stars, planets, and other celestial bodies. The remnants of the magnetar's magnetic field, the matter it once held, and the energy it once emitted, all contribute to the ongoing formation of the universe. While the magnetar itself may no longer shine with the intensity it once did, its death marks the birth of new possibilities. The universe, in its constant state of flux, carries the memory of its previous stars, each one contributing to the cosmic dance in ways that continue to shape the universe even long after they have passed. In a sense, magnetars represent a cosmic paradox. They are at once fleeting and eternal. Their lives are short, often lasting only a few million years, yet the effects they have on the universe extend far beyond their immediate death. In their brief existence, they contribute more energy to the cosmos than most stars will in their entire lifetimes. But this same energy which fuels the magnetar's power also leads to its eventual demise. The magnetar's fading magnetic field serves as a reminder that even the most powerful forces in the universe must eventually give way to something new. And yet even as they fade, their impact is felt. The magnetic fields they once generated continue to ripple through space-time, subtly altering the universe long after they have gone silent. The magnetar's death is an inevitability. All stars must eventually exhaust their fuel, and even the most powerful among them must eventually fade. But in the case of the magnetar, this decline is not a simple fading away. It is a complex, gradual process, as the star's magnetic field slowly dissipates and its bursts become fewer and further apart. Despite its eventual silence, the magnetar remains a part of the universe's grand design, a force that shapes the cosmic landscape and leaves behind traces of its existence. The energy it once emitted continues to shape the formation of new stars and galaxies, and its magnetic influence on the surrounding space persists long after the star has ceased to shine. What happens after a magnetar fades away is not well understood. Some scientists suggest that it becomes a regular neutron star, its magnetic field, no longer capable of producing intense bursts of radiation. Others propose that it may become an even more exotic form of matter, transforming into something entirely different in the process. But one thing is certain: the energy that the magnetar once emitted never truly disappears. The universe is a place of constant flux, and even in death, a magnetar contributes to the ongoing evolution of the cosmos. The forces it set in motion continue to reverberate throughout space, shaping the path of stars, galaxies, and cosmic phenomena for eons to come. The fading of a magnetar is a quiet event, its once loud pulses of energy dying down into the dark recesses of space. The magnetic field that once dominated the surrounding space slowly fades, and the energy that once radiated outward becomes more diffuse. Yet in this quiet fading lies a profound truth: the magnetar, though it may no longer be the radiant force it once was, remains a vital part of the cosmic cycle. Even as it weakens and fades, it continues to influence the universe, shaping the path of stars and galaxies for millions of years to come. This quiet presence is a reminder that even the smallest changes in the universe can have far-reaching effects. The magnetar may fade, but it leaves behind a legacy, one that continues to shape the universe, even as it slips into the silence of space. As the magnetar fades, its pulse weakens, its magnetic field no longer the dominant force it once was. It becomes a ghost, a remnant of its former self, yet still it exerts a subtle influence on the universe. The bursts of energy it once emitted are no longer as frequent, and the high-energy radiation it radiated is now a mere echo of its previous intensity. But even in this quiet state, the magnetar leaves behind something more significant than its physical presence. It leaves a mark on space-time, a lasting imprint that continues to ripple outward, carrying the memory of its existence through the cosmos. The magnetar's energy, though spent, is woven into the very fabric of the universe, reshaping its surroundings in ways that are not immediately visible, but are no less profound. The forces that gave birth to the magnetar and the immense energy it once radiated are now etched into the very structure of space, leaving a legacy that will endure long after the star itself has faded into the darkness. The fading of a magnetar is an inevitable process. Like all stars, it follows a natural life cycle, its brilliance eventually waning as it runs out of the energy that once fueled its immense power. Yet as it fades, it doesn't disappear entirely. The remnant neutron star that remains is still incredibly dense, a relic of the violent collapse that formed it. Even in its weakened state, the magnetar continues to influence its surroundings, albeit in more subtle ways. The energy it emitted during its most intense bursts continues to travel across space, lingering in the form of radiation and cosmic radiation. This energy may be faint, but it travels vast distances, crossing the expanse of the universe, shaping the space it passes through. The magnetar may no longer pulse with the same intensity, but its legacy endures, imprinted on the universe, like a fading song that continues to echo long after the music has stopped. It is a paradox that even as the magnetar's magnetic field weakens, its influence on the universe persists. The energy it once emitted continues to travel through space, carrying with it the signature of the star's existence. This energy, though now distant and faint, carries with it information about the magnetar's life, the forces that shaped it, and the cosmic processes that gave birth to it. The radiation, like faint whispers from the past, still reaches us, allowing us to study the magnetar long after it has faded. In this sense, the magnetar continues to shape the universe even in its death. Its energy, like the ripples from a stone thrown into a pond, continues to spread across space, touching distant stars, galaxies, and cosmic phenomena. These lingering effects remind us that nothing in the universe is truly lost, that everything leaves an imprint no matter how faint or distant it may be. But even as the magnetar's energy lingers, it is also a reminder of the transience of all things. The magnetar's brief life, though filled with immense power and energy, is ultimately fleeting. In the grand scheme of the universe, the magnetar's existence is but a moment, a brief flare of light that burns brightly before fading into the dark. Yet even in its brief existence, the magnetar leaves behind a lasting legacy. The energy it released, the matter it created, and the space it influenced are all part of the larger cosmic cycle. Like all stars, the magnetar's life and death are a part of the ongoing process of cosmic evolution. The forces that shaped the magnetar and the energy it released will continue to influence the universe long after the star has passed. The energy of the magnetar, though now faded, continues to travel through the universe, spreading out like a gentle current that shapes the space it passes through. The remnants of its magnetic field still affect the surrounding space, altering the orbits of nearby stars and planets, influencing the behavior of cosmic gas clouds and creating ripples in space-time. These subtle effects are a reminder that even the quietest forces in the universe leave behind lasting traces. The magnetar, though, no longer the vibrant, powerful force it once was, continues to shape the cosmos in ways that are barely perceptible, yet no less significant. The universe is full of such subtle forces, each one contributing to the ongoing evolution of the cosmos, leaving its mark on space and time. As the magnetar fades, it becomes a part of the cosmic cycle of creation and destruction. The energy it emitted over the course of its life will be absorbed by the surrounding space, eventually contributing to the formation of new stars, galaxies, and cosmic structures. The matter that was once part of the magnetar, the atoms and particles that made up its dense core, will eventually be recycled, forming the building blocks for future stars and planetary systems. The magnetar's death is not an end, but rather a transformation as its energy and matter are absorbed into the larger fabric of the universe. The magnetar, in its final moments, contributes to the ongoing evolution of the cosmos, helping to shape the future of the universe even as it fades away. In this sense, the magnetar serves as a symbol of the transient nature of the universe. Everything is in a constant state of flux, and even the most powerful forces eventually fade into the background. Yet even in their fading, these forces leave behind lasting impressions, shaping the universe in ways that are often imperceptible but no less profound. The magnetar, like all stars, is part of a larger cycle of birth, death, and rebirth. Its life and death are not the end of its influence, but rather a transition into a new phase of cosmic evolution. The energy it released, the matter it created, and the space it influenced continue to shape the universe, carrying with them the memory of the magnetar's brief but powerful existence. The fading of the magnetar is a reminder that all things in the universe are subject to change. Stars, no matter how powerful or radiant, eventually reach the end of their life cycles. Yet even in their fading, they leave behind traces of their existence, ripples in space-time remnants of energy, and the building blocks for future stars. The magnetar's death is not a tragic end, but a part of the larger ongoing process of cosmic evolution. And as the magnetar fades into silence, it leaves behind a legacy that continues to shape the universe, a reminder of the ever-changing nature of the cosmos. As the magnetar's influence begins to diminish, the energy it once radiated continues to stretch across the vast expanse of space, rippling outward like the final echoes of a once thundering voice. Its once intense pulses, which shook the very fabric of the universe, gradually fade, but the energy released in those final bursts continues its journey, traveling across light years. The cosmic radiation emitted by the magnetar during its most powerful moments leaves behind traces lasting imprints in the surrounding space that affect everything in their path. The high-energy gamma-ray bursts that once surged outward now travel quietly through the universe undetected by most, but still leaving their signature behind. These remnants, though faint and distant, serve as a reminder of the magnetar's powerful presence, even as it slowly retreats into obscurity. Its death is not the end of its story, but rather the beginning of its legacy, as the energy it once emitted continues to shape the universe long after the star has faded from view. This quiet legacy is carried not only by the radiation that still travels across space, but also by the very space-time fabric itself. The magnetar's intense magnetic field, though now weaker, continues to influence the surrounding space. The distortions it caused in the fabric of space-time ripple outward, stretching and compressing the space around it. These subtle effects, though imperceptible to our senses, continue to propagate through the universe, leaving a cosmic signature that lasts long after the magnetar has disappeared. The space around the magnetar remains altered, its shape permanently changed by the forces it once exerted. In this way, the magnetar's death is not a simple disappearance, but a transformation, a shift in the structure of space itself, marking the end of one phase of the universe and the beginning of another. The magnetar's fading also signifies the quiet end of one of the most violent and powerful phenomena in the universe. The energy it released during its active phases could be measured in terms of the energy output of millions of suns, yet all of that power was dissipated in bursts that lasted only moments, leaving behind only a faint echo. The irony of this is that despite the vast scale of the energy produced by the magnetar, it is but a fleeting moment in the life of the universe. The universe in its vastness continues to expand, and the magnetar's death is merely a passing event in the grand timeline of cosmic evolution. In just a few million years, the magnetar goes from being a beacon of power and energy to a quiet, fading remnant of its former self. The fleeting nature of such power serves as a reminder of the transient nature of all things in the universe, where even the most intense forces eventually fade into the background. Despite the magnetar's quiet demise, its impact on the surrounding space is anything but subtle. The energy it released while active continues to have an influence on the surrounding environment, shaping the formation of new stars and galaxies. The elements it produced, such as iron and nickel, are the building blocks for future generations of stars and planets. The magnetar, in its life and death, has contributed to the ongoing cycle of cosmic creation, seeding the universe with the materials needed to form new celestial bodies. It is a paradox that a star so powerful, so destructive, can give birth to the very elements that will one day form new stars, planets, and life. This ongoing cycle of birth and death is the essence of the universe itself, a reminder that every force, no matter how brief or powerful, contributes to the greater whole shaping the future of the cosmos. The magnetar's ultimate fate, however, is still shrouded in mystery. As it fades, it will eventually become a part of the cosmic landscape, just another remnant of a star that once blazed brightly in the night sky. The magnetic field will dissipate, the bursts of radiation will cease, and what remains will be an ordinary neutron star, dense, cold, and quiet. Yet even in this final stage it will continue to exist, its dense core holding the memories of its previous life, like a relic from the past. Some of these remnants may eventually be drawn into other stars swallowed by black holes or absorbed into the fabric of the universe itself. The fate of these stars is tied to the ongoing evolution of the cosmos, where nothing truly disappears but rather is transformed, its energy and matter restructured and reused in the creation of new celestial objects. As we observe the life cycle of magnetars, we're reminded of the larger process of cosmic evolution. Stars in all their forms are born, they shine, they burn, and they eventually die. Some, like the magnetar, die violently, leaving behind traces of their energy and magnetic fields, while others simply fade away, their light dimming over billions of years. Yet despite their individual ends, stars contribute to the larger cosmic cycle, enriching the universe with the elements needed to sustain life and form new generations of stars. The magnetar's death, though it signals the end of a powerful and unique phase, is just another chapter in the ongoing story of the universe, where energy, matter, and space are constantly being transformed and reshaped. There is an irony in the way that the universe works, where the most powerful and violent events like the death of a magnetar are often followed by moments of quiet. After the magnetar fades, the surrounding space may return to a state of calm, but this calm is only temporary. New stars will form, new forces will emerge, and the universe will continue its slow, inexorable evolution. The death of the magnetar does not mark the end of the universe, but rather the continuation of its cycle of rebirth and transformation. The energy it once released continues to travel outward, enriching the space around it, and contributing to the creation of new stars, planets, and galaxies. In this way, even in death, the magnetar remains a part of the ongoing cosmic dance, a force that continues to shape the universe in ways that are both subtle and profound. As the magnetar drifts deeper into its final stages, the quiet of its fading existence stretches outward, leaving behind only the faintest echoes of its once vibrant energy. The star's magnetic field, though now weakened, still exerts a subtle influence stretching across the expanse of space. The once intense bursts of gamma rays and X-rays are now rare occurrences, their energy diluted by the vast distances they must travel before they can be detected. Yet even in their diminishment, these remnants carry with them the history of the star's violent birth and brief life. The magnetar's death does not erase its existence. Instead, it leaves a trace, an imprint on space-time, a mark that remains in the wake of its passing. The universe continues its expansion, yet the magnetic waves and radiation emitted by the magnetar are still present, rippling through the vast emptiness like the final reverberations of a sound that has long since faded from our ears. Even as the magnetar's activity slows, the lingering presence of its magnetic field continues to shape the surrounding space. The space around it, once warped by the immense forces at play, now slowly begins to settle, yet the changes that were caused by the magnetar's powerful presence will endure for millions, if not billions of years. The energy released by the magnetar in the form of radiation and magnetic waves continues to travel outward, expanding through the universe, touching stars and galaxies far beyond the reach of the star itself. This energy, though faint, is a reminder of the magnetar's profound influence on the surrounding space. As the star fades into nothingness, its energy still carries with it the signature of its existence, faint but unmistakable like the fading warmth of a dying flame. The ultimate fate of the magnetar remains uncertain, but we know that it will eventually become a regular neutron star, its magnetic field finally giving way to a quiet, cold state. Its intense bursts will cease, its magnetic field will fade, and what remains will be an ordinary remnant of a once mighty star. And yet in its final moments the magnetar has played a significant role in the shaping of the cosmos. The radiation it emitted, the magnetic fields it created, and the elements it formed have all contributed to the ongoing evolution of the universe. The matter and energy it released into the cosmos have been incorporated into the fabric of space, where they will continue to influence the formation of new stars, galaxies, and planets. The death of the magnetar in this sense is not an end but a transition. Its energy may have dissipated, but its contribution to the universe is far from finished. The magnetar, like all stars, has followed a life cycle, but its brief existence stands as a testament to the power and unpredictability of the cosmos. It is born from the collapse of a massive star, its magnetic field growing stronger over time, and it eventually dies, its magnetic field weakening its energy, dissipating into space. Yet even in its death, the magnetar has left behind a legacy and imprint on the universe that stretches far beyond its immediate reach. The matter it created, the radiation it released, and the changes it caused in the surrounding space continue to reverberate across the cosmos, shaping the universe in ways that we are only beginning to understand. Even as the magnetar fades into obscurity, its influence lingers, shaping the formation of future stars and galaxies, a reminder that even the most transient of forces can leave a lasting impact. As we observe the death of a magnetar, we are reminded of the inherent transience of all things in the universe. The magnetar's existence was brief, lasting only a few million years in the grand scale of cosmic time, but in that brief span it burned brighter and more intensely than most stars could ever hope to. And yet, even as it fades, the magnetar's influence continues to shape the cosmos. The energy it emitted, the matter it produced, and the changes it wrought in the surrounding space are all part of the ongoing evolution of the universe. The magnetar may no longer shine with the same intensity it once did, but its legacy endures, its mark forever etched into the fabric of space-time. The universe is a place of constant change where stars are born, burn brightly, and eventually fade away. The magnetar, though it is but one of many stars that have existed and will exist, serves as a reminder of the dynamic nature of the cosmos. Every force, no matter how brief or powerful, contributes to the larger cycle of creation and destruction that shapes the universe. The magnetar's brief life may have been filled with intense bursts of energy and radiation, but in its fading, it becomes a part of the cosmic cycle, contributing to the formation of new stars, galaxies, and matter. The death of the magnetar is not an end, but rather a continuation of the ongoing dance of cosmic evolution, where energy and matter are constantly recycled, reshaped, and reformed into new forms. Even as the magnetar fades, its death marks the beginning of something new. The energy it released, the matter it formed, and the space it shaped all contribute to the ongoing creation of the universe. In this sense, the magnetar's death is not a loss but a transformation. It is a reminder that the universe is always in motion, always evolving, and that even the most powerful stars eventually give way to new forms of energy and matter. The magnetar, though it no longer shines, continues to play a role in the grand cosmic cycle, its legacy continuing to shape the universe long after it has faded from view. This cycle of creation and destruction is a fundamental part of the universe where even the most fleeting of forces can leave behind lasting effects. The magnetar's life may have been short, but its impact on the cosmos will last for billions of years. Its magnetic field, its bursts of energy, and the elements it formed all contribute to the ongoing formation of new stars and galaxies, and in this way the magnetar lives on. The universe, in its ever-expanding vastness, is shaped by the forces that come and go, each one leaving behind traces of its existence, contributing to the ongoing evolution of the cosmos. In this way, the death of a magnetar is not an end, but a transformation, a transition from one phase of the cosmic cycle to the next. The energy, the matter, and the space that it once influenced are now part of the larger universe, contributing to the birth of new stars, galaxies, and planets. The magnetar's legacy endures its fading pulses of energy, continuing to reverberate across space, shaping the universe in ways that we are only beginning to understand. And as the magnetar fades into silence, it becomes part of the greater cosmic story, its brief but powerful existence, a reminder of the ever-changing nature of the universe. The silent retreat of the magnetar into the shadows of the cosmos is not a disappearance but a shift. As its magnetic field weakens and the violent bursts of energy cease, it becomes something quieter, more subdued but no less important in the grand architecture of the universe. What remains is a neutron star still immensely dense with gravity so strong that even light is pulled into its depths. Yet as a magnetar fades into the past, its effect on the surrounding space doesn't simply vanish. Its magnetic field, once the most powerful in the known universe, continues to influence its cosmic neighborhood, if only faintly. For millions of years it remains as a subtle imprint, a quiet echo of the forces that once shaped its existence. This lingering presence is akin to the faint glow of distant embers, a quiet testimony to the power that once blazed across the dark skies of space. Even in its decay, the magnetar continues to exist as a remnant, a point in space-time that shaped the universe far beyond its initial birth. While its magnetic field weakens, the neutron star left in the wake of the magnetar retains a formidable presence. A neutron star is so dense that a single cubic centimetre of its material would weigh about 1 billion tons. This dense, collapsed core is a stark contrast to the violent magnetic nature the star once exhibited. The neutron star becomes an anchor in space, though no longer as dynamic. Its internal processes now far quieter. The neutron star's energy output is now far lower, but its presence is still profound. Over time it will continue to passively affect nearby matter, its gravity shaping the orbits of nearby stars and planets, but it does so without the energetic flares that once defined its life. The star's transformation from a magnetar to a neutron star symbolizes a slow and inevitable progression, a transition from the magnificent power of active energy bursts to the enduring but far quieter influence of gravitational forces. Even though the neutron star itself no longer produces the intense bursts of radiation that it once did, the legacy of the magnetar's energy continues to reverberate across the universe. The radiation emitted during the star's most active periods spreads outward, filling the surrounding space with traces of its former brilliance. These bursts of energy, though fading, still travel across the vastness of the cosmos, touching distant stars and galaxies. The particles and waves left behind by the magnetar continue to carry information about its birth, its life, and its death. In this way, the magnetar remains an active part of the cosmic network, influencing faraway phenomena even after its pulse has quieted. Its energy does not disappear. Rather, it continues to propagate, lingering in the space between stars, spreading throughout the universe, leaving a trace of its once mighty presence. Yet the lingering presence of the magnetar's radiation raises a subtle irony. This energy, once so powerful and overwhelming, becomes part of the universe's background noise. It is a faint whisper now, a remnant of the cataclysmic forces that once set it in motion, and yet it continues to travel. In the grand expanse of time, these residual traces of radiation will eventually fade, but for now they remain as a quiet reminder of the star's energetic past. This is a fundamental irony of the universe forces that once shaped and defined the cosmos, though now silent, leave their mark for eons to come. The echo of the magnetar's power, though it has faded into a background hum, continues to be a part of the greater cosmic story. The magnetar's legacy is also carried by the elements it created as its intense radiation enriched the surrounding space with heavier elements. During its bursts, the star fused lighter elements into heavier ones, an essential process in the creation of the building blocks of future stars and planets. These elements, scattered across the universe in the wake of the magnetar's death, continue to play a crucial role in the formation of new stars, new solar systems, and new worlds. The magnetar, though it is no longer an active force, has seeded the universe with the materials needed for the next phase of cosmic evolution. The materials that made up the magnetar, as well as those it created through its energetic bursts, are now part of the cycle of stellar birth and death. The legacy of the magnetar's energy, the elements it forged and the radiation it emitted, will continue to shape the evolution of the universe, creating the conditions for new stars and planets to form even in its absence. While the magnetar's magnetic power fades, its place in the cosmic cycle remains vital. It is a part of a much larger system, one where energy is not lost, but rather transferred and transformed. The energy that once powered the magnetar and caused its intense bursts has now been absorbed by space, spreading outward to affect everything it touches. In this sense, the magnetar's death is not an end, but a part of the continuous cycle of creation and destruction that governs the universe. The energy of the magnetar, though diminished, will continue to influence the universe long after it has faded from view, a quiet force in the ongoing evolution of the cosmos. Even in death, the magnetar remains a part of the universe's grand design, shaping the future of the stars and galaxies yet to be born. The magnetar in its fading also highlights the impermanence of all things in the universe. Stars, no matter how powerful, will eventually burn out their energy spent. Yet this impermanence is not a flaw, but a feature of the cosmic system, where nothing is ever truly lost. The energy that leaves a star, whether through radiation magnetic fields or the creation of heavy elements, continues to play a role in the evolution of the universe. The magnetar may no longer be the source of intense energy and magnetic fields, but its remnants continue to shape the cosmic landscape. It is through these cycles of birth, life, and death that the universe continues to evolve, growing and changing over time. Even as stars die, new ones are born, and the energy they release contributes to the ongoing transformation of space. In this way, the magnetar's legacy is one of quiet, enduring influence. Its death marks the end of a particular chapter in the life of a star, but it also marks the beginning of another. The energy it has released, the elements it has created, and the space it has shaped continue to resonate throughout the universe. Though the magnetar itself is now a fading memory, its impact on the universe is far from over. It continues to shape the world around it, its energy and matter influencing the creation of new stars, new galaxies, and new cosmic phenomena. The quiet retreat of the magnetar into the distant corners of space is not an end, but a continuation of the cosmic dance, a part of the ongoing evolution of the universe where nothing is ever truly lost and everything contributes to the larger whole. As the magnetar fades into silence, its power is not lost. It simply transforms, becoming a more subtle, less visible force in the universe. The star which once pulsed with violent intensity now exists as a neutron star with its magnetic field significantly diminished. The energy it once emitted so fiercely is no longer radiating in bursts that warp space-time and illuminate distant galaxies. Instead, it continues to influence the surrounding space in ways that are far more gentle but no less profound. The neutron star remains incredibly dense with gravity so powerful that even light cannot escape its reach. Yet in this phase of quiet existence, the star does not cease to shape the space around it. The matter it has created, the elements forged in the heart of its violent energy bursts, continues to influence the universe. These elements become part of the cosmic cycle, seeding new stars, new planets, and new celestial bodies that will one day form. The magnetar's legacy, though fading, continues to reverberate through space, transforming the universe in ways that we can barely begin to understand. The magnetar's gradual descent into stillness highlights the inevitable decline of all cosmic bodies. Just as the most powerful stars eventually exhaust their energy, so too does the magnetar, once a beacon of energy and light, now fade into a quiet remnant of its former self. Yet this fading is not a passive event. Even as the magnetar loses its brilliance, its remnants continue to contribute to the ongoing shaping of the universe. The material left behind by the star, the heavy elements produced during its bursts, becomes part of the cosmic dust that forms new stars, new galaxies, and even new solar systems. These materials are crucial in the formation of future celestial bodies, as they provide the raw materials necessary for the creation of the stars and planets that will follow. The death of a magnetar, then, is not a termination, but a transformation. The energy it has expended is recycled its matter, contributing to the ever-changing landscape of the cosmos. This process of recycling of transformation is a fundamental characteristic of the universe. Everything is continually reshaped and reborn, and even in death the magnetar plays a vital role in this process. As the magnetar's energy dissipates, it leaves behind a lasting imprint on space-time. The magnetic waves it once emitted may have faded, but the ripples they created continue to affect the fabric of space. The very nature of space-time has been altered by the magnetar's existence. Even as the star's bursts of radiation become less frequent, and its magnetic field weakens, the distortions in space that the magnetar caused remain stretching out into the far reaches of the universe. These subtle changes are a reminder that even the most fleeting of forces can leave an indelible mark on the cosmos. In a universe where everything is in constant motion, these imprints serve as records of the powerful forces that have shaped the universe. The magnetar's legacy, though quiet, now will remain its effect rippling outward for billions of years, continuing to influence the structure of the universe long after the star itself has ceased to exist. Even though the magnetar has long since faded from its violent active state, the cosmic radiation it emitted continues to travel through the universe, slowly dissipating but leaving a trace. The energy from the magnetar's bursts like ripples in a pond moves outward, crossing vast distances, touching distant galaxies and altering the space it passes through. Though these waves of radiation and energy are faint by the time they reach distant regions of space, they carry with them the imprint of the magnetar's existence. They are a silent record of the star's once powerful presence, a quiet testimony to the energy that once surged through the universe, bending space, warping time, and changing the cosmos. These echoes of the magnetar's activity persist, moving through the universe, shaping the way stars and galaxies form, and contributing to the ongoing evolution of the cosmos. The fading of the magnetar is a cosmic reminder of the transient nature of all things. Just as stars are born and burn brightly, they eventually die, leaving behind remnants that continue to shape the universe. The magnetar's death marks the end of an era, but it is not the end of its influence. It has played its part in the grand, ever-turning cycle of creation and destruction that governs the universe. Its life, though brief, has had lasting consequences. The elements it created, the radiation it emitted, and the influence it had on the surrounding space will echo through the universe for eons to come. The magnetar may be gone, but the mark it left on the cosmos remains a quiet legacy that continues to shape the future of the universe. This cycle of creation and destruction is a key part of the fabric of the universe. Stars, no matter how powerful, eventually burn out and fade, but in their death, they provide the raw materials for the next generation of stars and planets. The death of the magnetar is not an end, but a transformation, an essential part of the ongoing cycle of cosmic evolution. The energy it has released, the elements it has created, and the space it has shaped continue to affect the universe, providing the building blocks for the stars and galaxies that will follow. As the magnetar's fading light dissipates, the seeds for future creation are sown, and the universe continues to evolve, ever changing and ever growing. The Magnetar's brief, powerful life has contributed to the ongoing evolution of the cosmos, and though it is now silent, its legacy endures. The Magnetar, like all stars, has followed a natural cycle. Born from a supernova, it burned brightly with energy, releasing vast amounts of radiation and shaping the space around it. As it aged, its magnetic field weakened, and the bursts of energy became less frequent until finally it faded into a quiet, inactive state. But even in its silence, the Magnetar remains a part of the universe, its legacy continuing to shape the cosmos. Its death marks a transformation, not an end. The energy it once emitted, the elements it created, and the space it altered will continue to resonate through the universe for billions of years, shaping the future of stars, galaxies, and planets. The Magnetar, though gone, lives on in the echoes of its energy and in the ongoing process of cosmic creation. As the Magnetar's energy continues to dissipate, a new phase of cosmic evolution begins. The star's magnetic field may no longer dominate the surrounding space, but the residual energy it has released still influences the universe, quietly altering the course of stellar evolution. The faint echoes of the Magnetar's radiation, now travelling through the vast emptiness of space, continue to influence distant galaxies, distorting the fabric of space-time in subtle ways. The once mighty force, now quiet, has become a part of the greater cosmic system, leaving behind a legacy that stretches across light years. Though it no longer pulses with the same intensity, the Magnetar's influence endures in the very structure of the universe. The process of a star's life cycle, its birth, burn, and eventual death forms the foundation of the universe's ever-changing dynamics. The Magniel, though it burned brightly for a short period, has contributed immeasurably to the cosmic landscape. The energy it released, the elements it forged, and the space it shaped are all part of the continuing formation of new stars, galaxies, and planetary systems. Even in its death, the magnetar continues to fuel the creation of new matter, laying the groundwork for future cosmic bodies to take form. The universe, in its unending cycle of creation and destruction, absorbs the energy of these stars and reshapes it into new forms, breathing life into the vast reaches of space. What was once a radiant, pulsating beacon of energy has now become a quiet remnant, but that remnant remains a part of the cosmic tapestry. The Magnetar's death is not a solitary event, but a part of the ongoing cosmic cycle. Its transformation into a neutron star, though marking the end of its fiery bursts and intense magnetic influence, signifies its continuing role in the evolution of the universe. The matter and energy it released into the universe, the heavy elements it created, and the ripples it left in space-time all contribute to the ever-shifting balance of the cosmos. While the magnetar itself may no longer be the source of immense energy and light, its influence continues to be felt, its legacy woven into the fabric of the universe. Even as the magnetar fades into quiet existence, the cosmic forces that shaped it continue to exert influence on the surrounding stars and galaxies. The gravitational pull of the neutron star remains potent, subtly affecting nearby celestial bodies. This influence, though less intense than the magnetar's magnetic power, still plays a part in shaping the surrounding space. Stars and planets may find their orbits altered, and the space around the neutron star will continue to be influenced by its gravitational field. While the bursts of radiation have ceased, the neutron star's existence continues to shape the universe, adding another layer to the dynamic processes that govern cosmic evolution. Ironically, the quiet fading of a magnetar is a stark contrast to its fiery birth. From the catastrophic collapse of a massive star, a magnetar emerged its magnetic field, and energy bursts some of the most powerful in the universe. Yet despite its dramatic start, the end of the magnetar's life is marked by a slow, gradual retreat into the silence of the cosmos. This quiet transformation from a radiant force to a faded relic of its former self speaks to the transient nature of all things in the universe. The very forces that once fueled the magnetar's power are the same forces that eventually lead to its decline. The universe is a place of constant change, and the magnetar's death is simply another phase in the ongoing process of cosmic evolution. Despite this irony, the magnetar's legacy remains, and it serves as a reminder of the delicate balance in the universe. The intense forces that give birth to these stars' gravity-magnetic fields and the collapse of matter are the same forces that eventually cause their demise. The life cycle of a star is a constant interplay between creation and destruction, and the magnetar exemplifies this balance. Its birth marked by violent collapse, its life characterized by intense energy bursts, and its death marked by the gradual fading of its magnetic field, all demonstrate the eternal dance of forces that shape the universe. The magnetar's contribution to the universe is far-reaching. As it fades, its impact on the surrounding space continues to be felt. The energy released during its active life has been absorbed by the cosmos, altering the course of other stars and galaxies. The heavy elements formed in its bursts have been incorporated into the creation of new stars and planets, continuing the process of cosmic evolution. And the subtle distortions in space-time that the magnetar caused continue to ripple across the universe, shaping the paths of other celestial bodies. The magnetar, though it no longer shines with the intensity it once did, continues to shape the universe long after it has faded. In the grand scheme of the universe, the death of a magnetar is not an isolated event. It is part of the larger process of cosmic change. Stars are born, they burn brightly, and they eventually fade their energy, and matter recycled into new forms. The magnetar's death is simply one part of this cycle, a cycle that continues with every new star, every new galaxy, and every new piece of matter that is born from the remnants of those that have passed. The universe in its vastness is constantly in motion, evolving and changing, and the death of the magnetar is another chapter in this eternal process of transformation. This process is both beautiful and humbling. The magnetar's life, though brief, played a vital role in shaping the universe. Its energy, its matter, and its influence on the surrounding space all contributed to the ongoing evolution of the cosmos. Even as the magnetar fades, it leaves behind a lasting legacy, a part of the larger story of creation and destruction that defines the universe. The death of a magnetar is not the end of its influence, but a transformation into something new. It continues to shape the universe, continuing its journey through the cosmos long after it has faded from view. As the magnetar fades into the quiet stillness of the cosmos, its once mighty presence becomes a distant memory, a brief flash in the grand timeline of the universe. Yet even in this quietude, the legacy of the magnetar persists. The energy it emitted, though, now diffused across the vast expanse of space, continues to travel, carrying with it the imprint of the star's once vibrant existence. The light from the magnetar, though weak, now still exists as a faint echo of its power. The radiation that it released, the bursts of gamma rays and X-rays, stretches across the cosmos, its remnants reaching distant corners of the universe, where they may one day be detected by future generations of astronomers. Though the magnetar itself is no longer a beacon of intense activity, its energy continues to ripple through space, leaving behind a trace of its existence, like a distant fading star that continues to shine in the farthest reaches of the universe. The magnetar's impact on the surrounding space does not cease with its death. The forces it exerted during its active life, its immense magnetic field, and the violent bursts of radiation have altered the fabric of space-time itself. Even as the star fades, the distortions it caused continue to influence the surrounding space, affecting the orbits of nearby stars and the motion of galaxies. The space-time ripples created by the magnetar's energy continue to propagate, stretching across the universe like the aftershocks of a cosmic event. These ripples, though imperceptible to most, leave behind an imprint on the universe, shaping the way celestial bodies move and interact. The magnetar's influence, though no longer active, continues to reverberate through the cosmos, shaping the universe in subtle but significant ways. As the magnetar's radiation continues to spread, it serves as a reminder of the transient nature of the forces that shape the universe. In its brief existence, the magnetar burned with the intensity of 1,000 suns, a force of nature so powerful that it altered the space around it. But like all stars, it eventually ran out of energy, fading into the quiet stillness of space. This process, though inevitable, is not without meaning. The magnetar's life and death are part of the larger cycle of cosmic evolution, where energy and matter are constantly being transformed and reshaped. The magnetar's energy, though no longer visible, continues to play a part in the ongoing formation of new stars and galaxies, its influence lingering long after it has passed. This cycle of creation and destruction is a fundamental part of the universe, and the magnetar's brief but intense life serves as a reminder that nothing in the cosmos is ever truly lost. It is only transformed. The magnetar's fading energy continues to affect the surrounding space in ways that are still being discovered. The elements it created during its violent bursts, iron, nickel, and other heavy elements, have been scattered across the cosmos, enriching the matter from which new stars and planets are born. These elements, created in the furnace of the magnetar's magnetic field, now form part of the raw material that fuels the formation of new celestial bodies. The magnetar in its death has contributed to the ongoing cycle of star formation, its matter and energy now part of the larger fabric of the universe. The stars that will form from this material may one day themselves give birth to new magnetars, continuing the cycle of cosmic evolution. Even as the magnetar fades into obscurity, its role in the larger cosmic drama remains vital. The forces that created it, the magnetic fields and energy bursts that shaped its life, are part of the larger cosmic system that drives the evolution of the universe. The magnetar's brief existence may have been marked by violent energy bursts and intense magnetic fields, but its death is just another phase in the ongoing process of cosmic change. Stars like the magnetar are born, burn brightly, and then fade, but in their wake, they leave behind the materials and energy necessary for the next generation of stars to take form. The magnetar's energy, like all energy in the universe, is never truly lost. It is merely transformed, contributing to the creation of new matter and new stars. In this sense, the death of the magnetar is not the end, but a continuation of the cosmic cycle, where every force contributes to the ongoing process of creation and destruction. As the magnetar's influence fades, the space around it slowly returns to a state of relative calm. The violent bursts of radiation that once erupted from its surface become less frequent, and the magnetic field that once shaped the space around it begins to weaken. Yet even in this quieter phase, the neutron star that remains continues to exert a subtle influence on the surrounding space. Its gravitational pull, though less intense than its magnetic field, once still shapes the orbits of nearby stars and planets. This gravitational force is the legacy of the magnetar, a quiet reminder that even the most powerful stars leave behind a lasting imprint on the universe. The neutron star is no longer the source of intense energy and magnetic radiation, but its presence continues to affect the surrounding space, shaping the cosmic environment in subtle but profound ways. The fading of the magnetar, though marked by a gradual loss of energy and activity, is not a solitary event in the larger context of cosmic evolution. It is part of the ongoing cycle of creation and destruction that governs the universe. The magnetar's life, its intense bursts of energy, and its eventual death are all part of the larger process of stellar evolution, where stars are born, burn brightly, and eventually fade into the background of space. The energy released by the magnetar, though now diminished, continues to influence the universe, playing a part in the creation of new stars, new planets, and new cosmic bodies. The death of the magnetar, though marked by silence, is not an end but a transition, a continuation of the ongoing cosmic dance of creation and destruction that defines the universe. In the end, the magnetar's fading is not a loss but a transformation. The energy it once emitted, the elements it created, and the space it shaped continue to influence the universe long after the star has faded into silence. The magnetar's death is part of the larger cosmic cycle, where each star, each burst of energy, and each moment of creation contributes to the ongoing evolution of the universe. Though the magnetar is no longer a source of power, its influence lingers, continuing to shape the cosmos and contributing to the formation of new stars and galaxies. The quiet fading of the magnetar is a reminder that even the most powerful forces in the universe, though they may seem to fade, leave behind lasting marks that continue to shape the universe for eons to come. The magnetar in its quiet fading carries with it the complexity of cosmic evolution. As its powerful magnetic field weakens and its bursts of energy become less frequent, the star's once violent presence transitions into the subtle, lingering influence of a neutron star. This transformation is not sudden. It is the slow cooling of a once flaring entity, its fierce light now dimming into the calm silence of a remnant. However, even in this silence, the neutron star remains a force to be reckoned with. Its dense core, composed almost entirely of neutrons, is a place of unimaginable density, where gravity is so intense that it distorts space-time itself. The collapse that led to its formation was as dramatic as the magnetar's initial creation. But as the neutron star drifts further into its quiet state, the story of its violence becomes a whisper in the vastness of the universe. Still, the presence of this remnant, though quieter than its magnetar days, remains vital to the dynamics of the space it inhabits. Its gravitational field continues to subtly influence the motion of nearby stars, planets, and cosmic objects. The neutrons packed into its dense core continue to hold the star's essence, giving it a form of immortality in the cosmic sense, despite its transformation into a quieter, less energetic state. The neutron star is not without its own mysteries. Though it no longer emits the violent burst of radiation it once did, the magnetar's legacy persists in the forms of residual radiation and magnetic fields. The energy the magnetar released continues to travel through space, scattering across vast stretches of the cosmos. It moves outward like ripples from a stone thrown into a still pond, crossing light years, bending and warping space-time along the way. These faint signals, though weakened by distance and time, serve as lasting echoes of the star's once immense power. Even as the magnetar's radiation diminishes, these remnants leave a footprint on the universe like the faint traces left by a comet's tail. What was once an intense pulse of energy now becomes a quiet hum in the background of the cosmos, detectable only by the most sensitive instruments, but no less important for that. It is an enduring reminder of the magnetar's existence, its influence, and the indelible mark it left on the universe. In the fading quiet of the neutron star's existence, its gravitational pull remains a constant. Though its magnetic bursts have ceased, the density of the neutron star's core continues to exert a powerful influence on nearby space. Gravity, unlike radiation or magnetic fields, is not easily lost. The neutron star's immense mass creates a gravitational well that bends the space around it, influencing the orbits of nearby stars and the trajectories of other cosmic bodies. This gravitational effect, though subtle compared to the violent radiation the magnetar once emitted, continues to shape the fabric of space-time. The neutron star's legacy is now felt not in flashes of light or violent bursts, but in the quiet, steady tug of gravity. The universe's ongoing evolution is shaped not only by the birth of stars, but by their eventual transformation into dense remnants like the neutron star, which continues to influence its environment even as it fades from the initial violent state of a magnetar. But while the neutron star's role is now largely defined by its gravitational influence, there remains one final mystery. What happens to the neutron star as it continues to cool and fade over time? Some might say it will eventually become a black hole, its density increasing beyond all bounds, its gravity so strong that not even light can escape its pull. Others suggest that the neutron star will simply become a cold, dark object, a forgotten relic of a once vibrant force. But the fate of such remnants is still uncertain. The question of whether a neutron star will eventually collapse into a black hole or become a quiet, unremarkable object is one that has long intrigued astrophysicists. This uncertainty speaks to the mystery of stellar evolution itself, where even after a star has exhausted its energy, it remains a point of immense gravity and potential. The magnetar in its death leaves behind a neutron star that will either fade slowly into obscurity or transform into something even more enigmatic. Perhaps in this quiet transformation lies the ultimate lesson of cosmic life, that everything, no matter how powerful, eventually fades and is replaced by new forces, but the cosmic cycle never truly ends. The legacy of the magnetar is felt not only in the remnants it leaves behind, but also in the way it shapes the universe's future. The radiation, though now faint, continues to travel outward, its influence still detectable across great distances. The elements it created, heavy metals like iron and nickel, are now part of the cosmic dust from which new stars, planets, and even life will emerge. The magnetar, in its brief but intense existence, has seeded the universe with the materials that will shape the next generation of celestial bodies. As the star's energy dissipates, its matter remains a fundamental component of the universe's ever-evolving story. The magnetar may be gone, but it has left behind the building blocks for the next phase of cosmic creation. Even as one star fades, its matter is recycled and reused, contributing to the ongoing formation of the universe. In the long arc of cosmic time, the death of the magnetar is but one chapter. The universe continues to evolve, and the energy and matter that once defined the magnetar's existence now serve as the foundation for future stars. The magnetar's contribution to the creation of the elements, to the shaping of space-time, and to the ongoing evolution of galaxies is immeasurable. Its violent energy bursts, though now gone, have shaped the cosmic landscape in ways that we may never fully understand. The quiet death of the magnetar is simply a reminder that the universe, in all its vastness and complexity, is in constant motion, a perpetual dance of creation and destruction. The magnetar's death is not an end but a transformation, a step in the ongoing process of cosmic evolution. Its legacy continues to echo through the universe, shaping the stars, the planets, and the galaxies that will follow. The magnetar's existence, brief as it was, leaves behind a lasting imprint on the universe. The forces that created it, the energy it emitted, and the matter it forged are part of the ongoing cycle of cosmic change. The magnetar may have passed from view, but its legacy is not gone. The energy it released continues to reverberate through the cosmos, affecting the formation of new stars and the shaping of new worlds. The magnetar's death is simply the beginning of a new phase in the universe's evolution, where the materials and energy it once radiated continue to play a vital role in the creation of future cosmic bodies. The Magnetars fading does not mark the end of its story, but rather a new chapter one in which its influence persists across the vast stretches of space and time, a reminder of the ever-changing nature of the universe. The quiet retreat of the magnetar into the background of the cosmos is marked by the gradual but inevitable fading of its once dominant energy. What was once a star pulsing with immense magnetic fields and radiant bursts of gamma rays and X-rays has now become a neutron star, quieter, more reserved in its presence. But even as the magnetar's intensity wanes, its legacy is far from diminished. The magnetar's energy, though no longer pulsing outward in waves of light and radiation, continues to travel through space, its faint traces drifting across light years, touching distant corners of the universe. The magnetar may no longer be the force it once was, but its influence continues rippling through time and space, quietly shaping the cosmic environment. Its imprint on the fabric of space-time, once dramatic and forceful, now becomes a subtle distortion barely perceptible, but still significant, echoing through the universe long after its physical presence has quieted. As the magnetar fades its material, the dense matter created during its intense bursts of radiation becomes part of the ever-expanding universe. This material, enriched with heavier elements like iron and nickel, joins the cosmic dust that will eventually form new stars, planets, and possibly life. The magnetar's death is not a complete end, but a transformation, as the elements it has created continue to play a role in the ongoing formation of the cosmos. These elements, born from the star's violent processes, are now scattered across the universe, carrying with them the memory of the magnetar's existence. In this way, the death of the magnetar is a quiet continuation of the universe's cycle of creation and destruction, where matter is continually recycled, reshaped, and repurposed for new forms of existence. Even as the neutron star's energy fades, it still serves as a key part of the cosmic cycle. The forces that created the magnetar and the remnants of those forces remain present. The neutron star may no longer emit powerful bursts of radiation or influence its surroundings with the same force, but it continues to shape the space around it. Its gravity, though subtle compared to its former magnetic field, still bends the space-time around it, influencing nearby stars and planets. The magnetic field that once powered the magnetar is now diminished, but it still lingers, affecting the surrounding environment. This quiet presence of the neutron star, though no longer marked by the dramatic bursts of its past, continues to play a vital role in the evolution of the universe. Even in its decay, the neutron star remains a significant point in space, influencing its surroundings in ways that are both subtle and profound. Yet despite this subtle influence, the fading of the magnetar raises profound questions about the nature of cosmic life. Why, after such an intense and energetic existence, does the magnetar's influence slowly fade? What happens to the star's energy, its matter, and its very essence once it has expended its final burst? These questions remain unanswered, and perhaps they are part of the mystery that makes stars such as the Magnetar so captivating. In their brief moments of brilliance, they illuminate the mysteries of the universe, but as they fade, they leave behind questions. Questions about the ultimate fate of stars, the destiny of matter, and the nature of energy itself. The Magnetars fading is not just a physical process, but a reminder that the universe is full of unknowns, full of forces that defy our understanding yet shape the very fabric of reality. Even in its decline, the magnetar continues to challenge our perception of time, space, and energy. The immense forces at play in the creation and death of a magnetar push the boundaries of our scientific understanding. The energy it once radiated the elements it created and the distortions it caused in space-time serve as reminders that the universe is a dynamic, constantly shifting entity. The Magnetar's death is a part of this larger cosmic dance, a dance of creation and destruction, where every star, no matter how powerful or brief its life, plays a role in shaping the future of the universe. The energy released by the magnetar, though it has faded, is still present, carrying with it the imprint of its past and shaping the universe for generations to come. As the magnetar becomes a silent neutron star, the energy and elements it has created continue to reverberate throughout the universe. The matter from the magnetar's intense bursts forms the foundation of new stars and planets. Its radiation, though no longer visible, continues to travel its faint signals, carrying the memory of the magnetar's intense activity. These remnants of the star's existence remain in the universe long after the star itself has faded from view, contributing to the ongoing process of cosmic evolution. The magnetar's death, though quiet and unremarkable, is a part of the continuous cycle of creation and destruction that defines the universe. It is a reminder that even in the quietest of endings there is still a contribution to the greater whole, and that the forces of the cosmos are always in motion, always shaping the future. The fading of the magnetar also serves as a reflection of the impermanence of all things in the universe. Stars, no matter how powerful or radiant, will eventually burn out their energy spent. But even in their death, they contribute to the ongoing evolution of the cosmos. The matter they release, the energy they expend, and the influence they have on the surrounding space are all part of the larger process of cosmic change. The magnetar, though it no longer shines with the intensity it once did, remains a part of this cycle. Its fading is not an end, but a continuation of the cosmic dance, where the energy and matter of one star give rise to new forms of existence, to new stars, new planets, and new possibilities. In this way, the magnetar's death is a transition, a quiet step in the ongoing evolution of the universe, where nothing is ever truly lost but rather transformed into something new. The magnetar, in its quiet death, has become a part of the larger cosmic cycle. Its energy, though diminished, continues to shape the universe, contributing to the ongoing process of stellar birth and death. The elements it created, the energy it emitted, and the distortions it caused in space-time have all become part of the universe's ongoing evolution. Though the magnetar no longer burns with the intensity it once did, its legacy endures in the quiet influence it continues to exert on the surrounding space. Even in its fading, the magnetar remains a vital force shaping the future of the universe in subtle but profound ways. As the magnetar quietly fades, it transitions from a radiant powerhouse to a silent, enduring remnant in the cosmic tapestry. Yet even in this stillness, the neutron star that remains continues to exert its influence on the universe. Though the violent magnetic bursts have ceased, the gravitational pull of the neutron star remains as strong as ever. The dense core of the star, no longer engaged in energetic bursts, continues to warp the surrounding space-time, subtly bending the orbits of nearby stars, planets, and cosmic matter. This gravitational influence is long-lasting, stretching across time and space, shaping the paths of celestial bodies for millions, even billions of years. The neutron star's gravity, though quieter than the intense magnetic field of the magnetar, is no less significant. In fact, it is this constant invisible influence that persists long after the magnetar has faded from view. The universe continues to move in response to the forces left in the wake of the magnetar's existence, a reminder that the forces of gravity and space-time remain enduring elements of the cosmos. Even though the magnetar is now a silent neutron star, the impact it had on the surrounding universe during its active phases cannot be erased. The energy it released gamma-ray bursts magnetic field distortions, and radiation has travelled far beyond its point of origin, carrying with it the imprint of the star's violent past. These echoes of the Magnetars' activity continue to travel through the universe, spreading across light years and leaving faint traces in the cosmic background. Scientists are still able to detect the subtle effects of these waves, which carry crucial information about the star's death and its transition from an active magnetar to a passive neutron star. These waves, though faint by the time they reach Earth, continue to provide insight into the mysterious life and death of magnetars, offering a window into the violent processes that shape the cosmos. As the magnetar slowly fades into a quiet state, its once intense bursts of radiation, though diminished, still resonate across space. The radiation, though weak, still carries information about the star's violent birth and its eventual transformation. This persistent radiation continues to travel through space, creating faint echoes that extend through the universe, affecting distant stars, galaxies, and cosmic structures. In this way, the magnetar's death is not the end of its influence, but a continuation of its presence in the universe. The energy it once emitted has travelled across light years, and even as it fades, its effects can still be observed. The magnetar's death may have silenced its most dramatic bursts, but its lasting imprint on the universe remains. Its radiation and magnetic fields continue to reverberate throughout space, a reminder of the once mighty force it represented. The magnetar's transition from an active violent star to a quiet neutron star is a reflection of the cyclical nature of the universe. Just as stars are born, burn with incredible intensity, and eventually fade into quiet remnants, so too does the magnetar follow this cosmic rhythm. But even in its decline, the magnetar remains a crucial part of the universe's ongoing evolution. The elements it created during its active phases, the radiation it emitted, and the gravitational distortions it caused have all contributed to the larger process of cosmic creation. The energy and matter released by the magnetar continue to play a role in the formation of new stars, new planets, and new galaxies. The quiet death of the magnetar does not signify its ultimate disappearance, but rather its transformation into a different, more subtle force within the universe. Even though the magnetar's life has quieted, its death is a vital part of the universe's dynamic evolution. The creation of heavy elements through its intense bursts and magnetic processes has enriched the surrounding space with the building blocks for future stars and planets. The energy released in the form of radiation continues to travel, lingering long after the star has ceased to radiate with the same intensity. The neutron star left behind by the magnetar remains a powerful point of gravity, subtly influencing its surroundings. The magnetar in its death has contributed to the formation of new cosmic bodies, continuing the cycle of stellar birth, life, and death. Its death has paved the way for new stars, new forces, and new forms of matter to emerge. The universe is, after all, in a constant state of flux, and even in its quietest moments, the magnetar continues to shape the path of cosmic evolution. The magnetar's legacy, though now less apparent, is still a guiding force in the universe. The gravitational waves it emitted during its life have travelled across the cosmos, carrying with them the memory of its existence. These waves, though faint, continue to shape the space they pass through, altering the paths of distant stars and galaxies. The magnetar's death has not removed its influence. It has simply shifted the nature of its impact. Its radiation, its matter, and its gravitational distortions are still present in the fabric of space-time. The neutron star that remains continues to exert a quiet, invisible influence on the surrounding space, ensuring that the magnetar's legacy endures. The universe moves in response to the forces that were set in motion by the magnetar, shaping the future of stars, galaxies, and cosmic phenomena. The eventual quietude of the magnetar as it transitions from an active force to a passive neutron star serves as a reminder of the impermanence of all things in the universe. Even the most powerful stars, after burning brightly, eventually exhaust their energy and fade. Yet in their fading, they contribute to the ongoing process of cosmic creation. The magnetar's death is not an end but a transformation, one stage of the cosmic cycle, giving way to the next. Its energy and matter continue to play a role in the ongoing evolution of the universe, shaping the formation of new celestial bodies and influencing the cosmic landscape for billions of years. The magnetar's fading is simply part of a larger cosmic rhythm, a reminder that everything in the universe is in a constant state of change. In the vastness of the universe, the magnetar's life, though brief, leaves behind an enduring mark. The energy it emitted, the matter it created, and the space it altered continue to affect the cosmos, contributing to the formation of new stars and galaxies. The magnetar may have faded, but its legacy remains a part of the universe's grand design, an essential part of the ongoing cosmic story. Even in its quiet, diminished state, the magnetar's influence continues to shape the cosmos. Its death is not the end of its story, but rather a continuation, a transformation from one stage of the universe's evolution to another. The magnetar, in its fading, is a reminder that even the most powerful stars in their death continue to contribute to the larger cosmic cycle. The final stages of a magnetar's life represent the quiet conclusion of an intense cosmic event, a transition that encapsulates the delicate interplay between energy, matter, and time. As the magnetar fades into the state of a neutron star, its once overpowering presence in the universe is now reduced to a faint memory, yet the forces it unleashed continue to ripple through space. The energy it emitted during its active life, the gamma ray, bursts the magnetic flares. The intense radiation lingers in the fabric of the cosmos like the fading embers of a fire that once blazed with unyielding heat. These remnants travel outward, stretching across the vast expanses of space, their intensity diminished over the eons, but still detectable by our instruments, their influence continuing to shape the universe. In this quiet aftermath, the magnetar's legacy endures a subtle force that still plays a role in the universe's ongoing evolution. Though no longer visible, the imprint of the magnetar's power remains embedded in the cosmic structure, a silent but potent reminder of the forces that governed its brief but dramatic life. The remnants of a magnetar are not only found in the energy it emitted, but in the very space it occupied. The magnetar's intense magnetic field, though now greatly weakened, left behind a distorted area of space-time. This distortion continues to propagate, affecting the gravitational paths of surrounding stars and planets, subtly altering the cosmic landscape long after the magnetar has ceased its violent activity. This residual influence is an example of the far-reaching effects that even the quietest forces can have on the structure of the universe. The matter it created, iron, nickel, and other heavier elements, continues to spread across the universe, enriching the space with materials that will one day form the building blocks for future stars, planets, and potentially life. The energy that has dispersed into the vast reaches of space also remains a source of information, a cosmic record of the magnetar's once powerful existence. This record, written in radiation and gravitational waves, continues to shape the cosmos in ways that are subtle but important, contributing to the ongoing cycle of creation that defines the universe. In the fading of the magnetar lies a lesson in cosmic impermanence. The star, once a towering beacon of energy, now retreats into quietude, its dramatic life, an explosive death giving way to a slower, quieter existence. But this silence is not an end. It is a transformation, one that mirrors the eternal rhythm of the universe. The magnetar's transition to a neutron star, though marked by a loss of energy, is still a vital step in the larger cycle of stellar evolution. The star's materials, its energy, and its magnetic influence are all repurposed in the formation of new stars and cosmic bodies. The cycle of birth, death, and rebirth continues with the death of one star contributing to the birth of another. Even in its death, the magnetar is part of the ongoing process of cosmic change, helping to create the conditions for new forces, new bodies, and new systems to emerge in the future. The universe is in essence a place of constant transformation. Even the most intense forces eventually give way to others as stars burn, brightly age, and ultimately fade. Yet the contributions of these stars, whether through the creation of elements, the release of energy, or the distortion of space-time, continue to affect the universe long after the star has passed from view. The death of a magnetar is not the end of its impact, but rather a shift in its role. It becomes a part of the larger cosmic machinery, its energy and matter, continuing to influence the formation of new stars, the creation of new planets, and the evolution of galaxies. The quiet fading of the magnetar into a neutron star is a transition from one form of existence to another, from a radiant source of energy to a gravitational anchor in the cosmos. But in both states it continues to play a crucial role in the shaping of the universe. As the magnetar's energy dissipates, it serves as a reminder of the finite nature of even the most powerful cosmic phenomena. Its life was brief in the grand scale of the universe, lasting only a few million years, yet in that time it altered the structure of space-forged heavy elements and released vast amounts of energy into the cosmos. These forces, though no longer active, have left behind lasting marks on the universe. The magnetar's death, then, is not an end, but a transformation into something more subtle, its legacy carried on in the ongoing evolution of the cosmos. The neutron star that remains, though no longer radiating with the same intensity, continues to exert a quiet influence on the universe, shaping the paths of nearby stars and planets, affecting the fabric of space-time and contributing to the creation of new cosmic structures. In this way, the death of a magnetar is part of the larger story of cosmic change, a story that is driven by the forces of creation and destruction. Stars, whether they are magnetars or ordinary stars, are part of a larger cycle of cosmic evolution. They are born, they burn with incredible intensity, and they eventually die, leaving behind remnants that continue to shape the universe. The energy and matter released by these stars are never truly lost. They are transformed, recycled, and repurposed, contributing to the creation of new stars, planets, and galaxies. The magnetar's death is simply the next step in this ongoing process of cosmic renewal, where the end of one star's life marks the beginning of another's. The quiet retreat of the magnetar into its final passive state is a reminder that even the most powerful forces in the universe eventually fade. Yet in their fading, they continue to influence the universe, contributing to the ongoing creation of new cosmic bodies and new forms of matter. The magnetar's legacy is not only in the energy it released, but in the way it shaped the universe around it. The neutron star left in its wake continues to affect the surrounding space, its gravitational pull bending the paths of nearby stars and planets, its magnetic influence lingering though diminished. Even in death, the magnetar remains a part of the cosmic cycle, influencing the universe in ways that are subtle but profound. The magnetar's journey through life and death is a testament to the dynamic, ever-changing nature of the universe. Stars are born, they burn with incredible intensity, and they eventually fade, but in their wake, they leave behind the materials, energy, and gravitational forces that continue to shape the future of the cosmos. The magnetar's legacy, though, now quiet, continues to influence the universe long after its death. Its energy, its matter, and its influence on space-time persist, contributing to the ongoing cycle of creation and destruction that defines the universe. The death of the magnetar is not an end but a transformation, as its once mighty power fades into the background of the cosmos, leaving behind a subtle but lasting imprint on the universe.